Okay, let's see. So this is a complex number. We go way back to 2022 July, 4th of July. Okay. So, okay, numbers, complex number system. So we have a number system NZQRC complex number. So I believe you already know the number system. Okay, x squared plus 1 equals to 0, x squared equals to minus 1. So x equals to plus minus I. Okay, then we have solving the quadratic. Then we have the real component and the imaginary component. Okay, then we have the basic operation. You are required to know how to do plus, minus, multiply, divide, power, square root. Okay. So then we have how does the two numbers add together, minus together, multiply together. Okay. What does it mean by the conjugates? Okay. So the plus sign change to the minus sign change to the plus sign, and we have it when we do divide. So we divide, we are at the bottom. We have to multiply by the conjugate of the bottom. Okay, then we have this way of calculation. During P3, you must able to show the working. Okay, and final presentation you must write them in the real and imaginary form. Okay, of course you can actually use a calculator to actually figure out the answer, and at the same time, okay, you have a power, so power 1 plus 2i power 5. Okay, of course we can actually press calculator to actually get the answer. Okay, or we can for P3 wise we will have to do an expansion. Okay, for FP2 of course we will expect students to know how to do it in the fast way. Okay, so this is by using binomial expansion. When we do square root, we cannot do square root. Okay, because of from the calculator. So we will need to use comparing method. Okay, so square root of negative 5 plus 12i, so 4x plus iy. So we square both sides, we expanded, then we compare the real component and real component, imaginary component. Then we solve simultaneous equation, then we have this form. Okay, this is what we did during July 4th. Okay, then let's go for another one. Open to July 4th, July 12th. Okay, then after that, okay, after the square root form, okay, you are required to know how to solve polynomial. Of course, we have the quadratic form. Then we have the cubic form. A cubic form, we have three answers. Then you must able to actually find the factor. Of course, during during exam, you can actually use a calculator to actually figure out the answer straight away. But that only works for real coefficient polynomial. Okay, real coefficient. As you can see, the coefficient of x cubed here is 1 and the constant is negative 8. They are all real number. If it's a imaginary number, the calculator will not be helpful. You still need to go back to the concept of long division, factor theorem, remainder theorem to actually help you to figure out the answer. Okay, if it's a real coefficient, then you will see that the complex root pair, the conjugate pair will always be the roots of it. Okay, so this is an example that is not a example of not real coefficient. Okay, questions. Okay, then this is the example of the real coefficient questions. Okay, as you can see, we have discussed from the past. Okay, we can actually do up to power 4. Okay, so if the question given like this, saying that 3 plus I is one of the root, then automatically 3 minus I is another root. Then you expand to create another quadratic form. Then you divide, you get another quadratic form. Then in order for you to get all the answers. Okay. So next, you are required to know three forms of complex number. From the past, you'll see that whatever that we did, we do it in the form of real and imaginary form, x plus iy. Okay, where x is the real component, y is the imaginary component. Then we have the modulus argument form, r and theta, where r is representing the distance from the point to the origin, and theta is the position angle. Okay, then we have the Euler form. Okay, z equals to r e I theta. It's the same r here, the same theta here. Then in other words, e I theta is equals to cos theta plus I sin theta. I hope you still remember the proof. So far so good. Up to whatever that we explain here.
Yes.
Okay. Then, um, then of course you are required. You can actually use the calculator to actually figure out how to actually find in between of the real imaginary form and the modulus argument form. Okay. So, for example, 1 plus I you press using the calculator r theta, then you'll get a square root 2 angle 45 like this. Okay, as your answer. Okay, or the other way around. So you of course please remember that your angle is the opposition angle. Don't just simply give me any random number. Okay, it's the position supposed to be able to represent its correct location. Okay, where a equals to r cos theta, b equals to r sin theta, r equals to square root of a square plus b square, theta equals to arctangent of b over a. So the a here is the real component, the b here is the imaginary component here. And the proof, okay, the proof, we did discuss about this proof before. So ei theta equals to cos theta plus I sin theta. So let z equals to cos theta plus I sin theta. dz d theta equals to negative sine theta plus I cos theta. Differentiate. Negative 1 serve as a I square. Therefore, it can be replaced in this form. You take out the I. You see that inside here, cos theta plus I sin theta is exactly the z that we have previously. Then from integration, we bring the z to one side, okay, the rest on the other side. We have a ln z equals I theta. At this moment, we ignore the plus c. Then from here, okay, we have a z equals to ei theta. Okay, so this is on from the date of 12th of July. Okay, this is on the date of 12th of July. Then after that, open. Let's see. FP2, 12th of July. 18. Let's see what they have. Okay, so until 18th of July, we already done with the algebra. We have already done with the tree form. Then you are required to know some complex algebra. Okay, you are required to know some. Of course, over here you are required to know it with proof. For example, of modulus of z1, z2 equals to r1, r2. So modulus of z1, z2 is equals to modulus of z1 times by modulus z2. Modulus of z1 over z2 is equals to modulus z1 divided by modulus z2. Modulus z power n equals to modulus z, the whole thing powered by n. The modulus of the z conjugate equals to modulus of z. Okay, argument of z1, z2 equals to argument of z1 plus argument of z2. Argument z1 over z2 equals to argument of z1 minus argument of z2. Argument of z power n equals to n times of argument of z. Argument of z conjugate equals to negative argument of z. Okay, so from 1 to 8, they are for the general rule. Okay, you are expected to know the relationship in between the modulus and the argument. Then from 9, if r equals to 1, if the modulus is actually equals to 1, then we see that 1 over z is the same as the conjugate. Therefore, comes to the important part that you are expected to remember. Okay, so over here, when r equals to 1, z plus 1 over z equals to 2 cos theta. Okay, then z minus 1 over z equals to 2 I sin theta. Zn plus 1 over Zn equals to 2 cos n theta. Zn minus 1 over Zn equals 2 I sin n theta. And 14, we have a z times z conjugate equals to modulus z square. This is your complex formulas, algebra formulas that you are expected to remember. Okay, are you okay with this?
Yep.
The rest, okay?
Yeah.
Then we talk about the application, okay, showing the application. So how do we actually see this? Okay, you can see that the modulus of Z1 is 5, modulus of Z2 is square root 5. So modulus of Z1, Z2, you can actually multiply them together. Only you do, you still get 5 square root 5. You can see that the rule is true. Okay, of course, during exam, it's not going to be a simple case like this. Most probably, they are all in the form of algebra. Okay, in no numbers, will be all A, B, C, D. So you are expected to know how to do your algebra work properly. Okay, so proof, we have the long proof, we have the short proof. Okay, a long proof we can do it in the form of modulus argument form. Okay, z1 z2 r1 cos theta I cos theta 1 plus I sin theta 1 z2 equals to r2 cos theta 2 plus I sin theta 2. This whole thing bring it here, this whole thing bring it here. We do. We show that the r1 equals to r2. This one most probably we did it on the board. Okay, then we have from here we actually see two conclusions that we see modulus z1 z2 equals to r1 r2, argument of z1 z2 equals to theta 1 plus theta 2. Okay, then we have the short version. Okay, z1 equals to r1 ei theta 1, z2 equals to r2 ei theta 2. Multiply them, then you have this rule. The sad part is the question may ask specifically to prove like this or like this if they ask. If they ask about the long proof, you need to show the long proof. You are expected to know. Do you still remember how to do? There is a blank here. Anyone want to explain? What will be the strategy to achieve this? Okay, never mind. We can you can actually take your time to do revision first. Okay, so this one is on the 18th of July. Then after that, 19. Let's see. So, okay. Then after that, we enter the geometry part of complex number. Okay, we enter the geometry part of complex number. So, for the geometry part, okay, the modulus of z1 minus z2, okay, representing distance between 2 points. Okay, r is z equals to k representing vertical line. I am z equals to k representing horizontal line. Okay, z conjugate representing reflection at x-axis. Okay, modulus of z minus z1 equals to r, representing circle center z1, radius r. Modulus of z1 minus z2 equals to modulus z1 minus z2 is a perpendicular bisector. Z minus z1 equals to k times of modulus of z minus z2, where k is not equal to 1, then it will be a circle equation. And 8, argument of z minus z1 equals to alpha is a half line. Then argument of number 9, argument of z minus z1 over z minus z2 equals to alpha is an arc of a circle. Okay, we did discuss about this drawing several times. And the best part to actually remember this is, okay, if you wish to prove, you can actually always write them in the Cartesian form, then actually figure out the shape, or you actually memorize them to actually draw the shape immediately. But of course, no matter what you do, make sure you do it within the 2 hours of your exam. Then from here, okay, modulus of z1 minus z2, you can see that how we actually do the calculation. Okay, so this one actually tell you that it's a distance formula. Number 2, you can actually see why is it a vertical line. Okay, this one. Number 3, why is it a horizontal line. Number 4, why is it a reflection. Number 5, why is it a circle. Okay, number 6, why is it a perpendicular bisector. Okay, you can see by using example. Number 7, how come it's become a circle equation? Because it simply fulfill the circle formula. Okay, so you are expected to remember the circle formula. Okay, then we discuss about how to actually do that in the thinking way or the looking at the formula of equation way. Of course, for me, if let's say I lazy to think, I will just go straight to the algebra. I just do, make sure all my algebra is correct. All my numbers here are all consistent. No, nothing goes wrong. Then I will be confident with my value. Okay. Then over here, okay, a diagram method. So diagram method is the thinking part, the how we actually do the thinking. Number 8, okay, is a half line. So how to actually do the equation? That only half of them is actually correct. Okay, we can use test point to actually figure out which part of the line is actually what we want. Okay, that will be number 8. This will be 19th of July. And after that, okay, then we have an arc of a circle. Okay, argument of z minus z1 over z minus z2 equals alpha. Okay, z1 and z2 are two fixed points. Okay, z is the moving point. Alpha is the fixed angle. So it can be written in this form. This can be written in this form is because of our complex algebra rule. Okay, remember argument of z1 divided by z2 is actually theta 1 minus theta 2. This is the reason why it can be written as a minus. Okay. Then from here, I have argument of z minus I over z minus 1 equals to pi over 4. We actually can write the Cartesian form. We do the algebra until I get the equation, the Cartesian form. I get x squared plus y squared equals 1, a nice number. Then the thing is, which way should I draw? So the 2 points that we have is I and 1. So I have a 1i and 1 here. From the entire circle of z x squared plus y squared equals to 1, this I have this entire blue circle. But these 2 points here, separate them into the minor arc and the major arc. Minor arc and the major arc. So we can actually use test point method to actually figure out which one that we want. Then after that, we okay, we realize that this is the final answer after we use the test point method. Okay. And this will be the example that you are asked you to do it by yourself. Okay, this will be this one is on the 25th of July. Then next, okay. So a specific type of question. Okay, we have a maximum and the minimum. Okay, questions. Okay, this is a maximum or minimum question. When you do this P3 question, you will see that this type of questions appear. The maximum of the maximum of the angle or maximum distance or minimum distance. Okay, then after that we also have complex inequality. Okay, that is related to complex geometry. So whatever that we have discussed earlier, okay, whatever the geometry shape that we have actually explained over here, it's just that this time is in the form of shaded region. Okay, it's in the form of shaded region. R is z greater than 2. What does it mean? Okay, I am z greater equals to 2. What does it mean? Okay, you will see that there is a dotted line and a solid line here. Okay, still remember what is it? Dotted line and the solid line. Then we have the modulus z less or equals to 2. Okay, or modulus z greater than 2. Okay, then we also have a modulus of z minus 2 less or equal to z minus I. So we have the number line, we have the straight line, perpendicular bisector, then we have to determine which side that is supposed to be. Okay, or even the argument, okay, the half line, so it can be covered within a certain area. Okay, this is all the shaded region. So, or finding the common area that fulfilled by the two different locations. Okay, fulfilled by two different locations. So this is all the questions that we have done before. Okay, then from here, okay, we do the example. Okay, solve the equation, quadratic equation. We solve. Okay, sketch the diagram. Okay, then find the modulus argument. Find the modulus argument. Show that the origin and its point representing a vertex of an equilateral triangle. So show that it's an equilateral triangle. So you actually can show that three the same length, or depends on which one how you want to do it. That's fine. Okay. So as you can see, you can actually relate the algebra with geometry here. Okay, so for example, the second question, complex number minus 2 plus I, okay, denominated by u. So this is a power tree. We want to solve k. We substitute by using factor theorem. Okay, we get a k equals to 20. Substitute the number inside. Then write down the other root. So it's a conjugate, okay, of it. Then find the modulus and argument of u. Okay. Then we have a square root 5 and 153.4 degree. Okay, this one. Okay, then sketch the Argand diagram to representing by the u. Okay, shade the region who's representing the complex number z. Then so for modular z lesser than modular z minus 1, so we have z minus 2, we have 2 here, we have 0 here. This is a perpendicular bisector. Then therefore we shaded this side. Then 0 to pi over 4. Okay, for z minus u is over here. Okay, or minus 2 plus I, minus 2 plus I. Then this is the region. Okay, from angle 0 to 45 degree. Then therefore we shaded this region. Okay. Then they want to state the region whose point representing the complex number satisfy both inequality. So in the end, this is we didn't complete the question. In the end, we have to combine these two and find the common region in between. Okay, to find the common region in between. Then we have the algebra question. Okay, negative 2 plus I, 3 plus I. So we'll do all the kinds of algebra. We'll find state the argument. Okay, then again is the shape question, Argand diagram, ABC representing this, show that the ABO is this angle. Okay, 3 over 4 pi. So I show you by using algebra method. Okay, state fully the geometry relationship between the line segment OA and BC. Then you realize that they are parallel. Okay. Then we also have complex number that actually combine with other topics, okay, especially with trigo or exponential and log. Okay, so we have a 1 plus cos 2 theta. So 1 plus cos 2 theta, we will see that is a real component. Sine 2 theta is the imaginary component. So we do the calculation. Okay, then we have the modulus equals to 2 cos theta. Of course, this is a proving of the trigo thing. Okay, and the argument is theta. You have argument of theta. And prove that the real part of 1 over z is a constant. So do the calculation. Multiply by the complex conjugate. Okay, then we do solve the equations, everything. Then you have a 1 over 2. Of course, the working is actually look very long. Okay, this is the part that I say that sometimes students are required to write the working in 2 pages. This will be the type of questions. In FP2, we actually see more of it. Okay, then we also have this. Okay, question. 1 over 2 cos theta is just a fraction. It's just a multiple, therefore it doesn't carry any meaning. Then you actually can go for this. So cos of negative theta is actually cos theta based on P1. So cos theta here cancel off. You're left with 1 over 2. This is on the 26th of July. Okay. Of course, there are quite a number of things that need to recap for here. But the quick recap. So to actually help you to understand what are we going to do in FP2. Okay. Open. Hmm. 26. Then after that, 5th of September already. Okay. So that means we only stop by then. Well, so we haven't really continued with the complex component of the complex part of it. Okay, the complex part of it. Where is the book? Let me check. What are the things that we haven't really covered yet? Okay. Let's see. let's see what else do we need to do for the complex number in FP2. Okay, we already covered quite a lot actually, in fact. Okay, let's see what else do you think do you need to do. Okay. We are loading the book now. So far, so good. Any problem, please tell me. If you do have problems. If you have any issues.
No problem.
No problem. Okay, so far so good. Okay, then allow me to continue with the complex number. Okay, of course, at this moment, we will assume students already okay with the all the P3 rules already. Okay, now we enter the FP2 component. P2 complex number. Okay, the first thing that you need to know that you need to learn from this chapter is something called De Moivre theorem. Okay, from P3, we already seen some relationship such that modulus of Zn equals to modulus of modulus of Z power by n, and the argument of Zn, okay, equals to n times of argument Z. Okay, therefore over here we will have this relationship that Z power n, okay, or R ei theta power n. Of course, it will be Rn ei theta n, and Rn ei n theta, which is the same as Rn of cos theta, cos n theta, plus I sin n theta. Okay, so we have this rule. So this rule over here, we call it De Moivre theorem. Okay, this relationship here, we call it De Moivre theorem. Therefore, to handle these topics specifically, I split this De Moivre theorem into DMT1 and DMT2. Okay, DMT1 and DMT2. So DMT1 says if Z equals to R e I theta, then Zn equals to R e I R n e I n theta. So this one shouldn't be anything special. Okay, it just put the power inside. Okay, but it's more specifically it's all for the modulus argument form. Okay, therefore we know that this is true. Okay, then DMT2. Okay, DMT2. If Zn equals to R e I theta, please see the difference. Can you notice the difference or not? Can notice the difference or not? Okay, don't confuse with it. Okay, this is Z equals to R e I theta. This is Zn equals to R e I n theta. I theta. Then roots Zk equals to R of 1 over n e I theta plus theta over m plus 2k pi over n for k equals to 0, 1, 2 until n minus 1. So what important is you need to know how to apply DMT2. Okay, you need to know how to apply DMT2. Okay, I'm going to show you. So from P3, if we can, maybe the question asks you to solve z cubed minus 8 equals to 0. This is a polynomial question, right? Power of 3, right? Okay, so if in P3, we will solve it this way. Okay, so I do factorization. So I will have a z minus 2 z squared plus 2z plus 4 equals 0. Still remember how to factorize? Okay. Then after that, we have a z equals to 2 with one of the answer. Then I have a z squared plus 2z plus 4 equals to 0 is another answer. Okay, from here I can find its complex conjugate. Okay, the complex answer. So I have a z plus 1 the whole thing square equals to minus 3. Okay, so z equals to minus 1 plus minus square root 3i as your answer. So we have three answers. Z equals to 2, z equals to minus 1 plus square root 3i, or z equals to minus 1 minus square root 3i. Are you okay?
Yes.
Okay. Can you do some work, press your calculator and tell me it's it's modulus and argument in the written in the Euler form. Give me the answer in Euler form. Lại. Give me the answer in Euler form.
Is it just 2 for the first one?
2 is not enough. 2 EI
0.
0. Thank you. The second one.
Is it 2EI pi over 3?
Pi. Oh,
Negative pi over 3.
which one is negative pi over 3? This one, this one.
Second. I mean the first one.
Pi over 3. Pi over 3 fall under first quadrant. This is not in the first quadrant.
2EI 2 pi over 3.
Okay. And the last one.
2EI 4 pi over 3.
Negative 2 pi over 3.
Oh, okay.
We write the position angle from negative 180 to 180. Okay. This is what happens if we solve it by using P3 for FP2. If let's say I have the same questions. Okay, so that means I can write it in this way, equals to 8. So since it's equals to 8, that means I also, of course, I can express them in the Euler form, as a Euler form. So I will have 8ei0. Do you agree?
Yeah.
Okay. Now try to capture this, huh? Now try to understand this, huh? Okay. Since I can write them in the form of z power 3 equals to 8ei0, therefore I will have roots. Okay, I will have total of 3 roots. I will have z of 0, z of 1, z of 2. The root will be 8 power 1 over 3, 8 power 1 over 3, 8 power 1 over 3, e I of this one. This is, since this is 0 here, so this is 0 plus 0 divided by 3. So I will just 0 divided by 3. Okay, ei is 0 divided by 3. Ei 0 divided by 3. And the k, static followed by its position. The k, this is k. So of course this one will be a 0 here. This is 0. The first one will be 0. Okay, this one will have a 2 pi over 3. This one will be a plus 4 pi over 3. Are you able to follow so far? I haven't write the final answer. I just want to see whether you can follow or not.
Yes.
Okay. Then I'll further simplify. 8 power of 1 over power of 1 over 3 is 2 e I 0. 2 e I 2 pi over 3. 2 e I, this is 4 pi over 3. Of course, I can write them according to its position. Negative 2 pi over 3. You have the 3 answers, which is exactly the same. This is how we use DMT2. Questions? Any problem?
No questions.
Okay. Okay. The next section is using. Okay, this one, what did I write? 1, 2. This one, 2. Using DMT and complex algebra to solve trivial questions. Okay. Now, okay, we already have the whatever that we have learned above. So now we have to deal with trivial equations. Okay. Okay, then over here, okay, the type A. Okay, change power. This one is the first type is called. The first type is called change multiple and multiple. The first type is called changing multiple angle to single theta. Multiple theta to single theta. That's the type 1. Okay. Give me sine or cos. Tell me. Give me something. Sine or cos.
Cos.
Cos. Okay. Cos. Give me a multiple of theta. Something times by theta. How many? Not too big.
5.
5 theta. Okay. Okay, so I would like to figure out what is a cos of 5 theta. Okay, that's my objective. Okay, that's my objective. So of course, at the moment, I have no idea what the answer is. So I'm going to use DMT, complex algebra, to actually help us solve the problem. So how do I actually start? Okay, I start with cos 5 theta plus I sine. I start with cos theta plus I sine theta power 5. Start with. Okay, so power 5 because the 5 theta that you want to do. Okay, cos theta because there will be some component inside that I can actually use. So cos theta plus I sine theta equal according to binomial expansion. Okay, I will have a cos of 5 theta plus 5 of cos 4 theta I sine theta plus 10 of cos 3 theta I sine theta square plus 10 of cos square theta I sine theta cube plus 5 of cos theta I sine theta 4 plus I sine theta 5. Do you agree with the uh, binomial expansion?
Yes.
Yes.
Okay, according to DMT, this cos theta plus I sine theta, according to DMT, it will give us cos of 5 theta plus I sine 5 theta. Do you agree? By DMT.
Yes.
Okay. My objective is to get cos of 5 theta, right? Therefore, over here, I compare real component. Compare real component. So I will have cos of 5 theta equals to, I trying to extract the real component from here. I have a cos of power 5. I have a minus 10 of cos cube theta sine square theta. Then I have a plus 5 of cos theta. I don't have sine of theta power 4. Done. Whatever the question one is changed, we can actually change according to this. Arrange according to what question one. But basically, that's what how do we actually extract. Are you okay?
Yes.
Okay, as you can see, it's very, very simple. A, okay, changing multiple theta to a single theta. Number type B. Type B, okay, change power more than 1 to power 1. Okay, change power more than 1 to power 1. The first one is change multiple theta to a single theta. Okay, this is number 2, is changing power more than 1 to power 1. Okay, just like above, you want sine or cos?
Sine.
It's okay, sine. Sine theta, what power do you want? Not too big?
4.
4. Okay, so that's my objective. Here, I want to deal with sine theta power 4. Okay, I want to reduce the power 4 into power 1. Okay, so therefore, because I'm using sine, based on a complex algebra that we have learned before, okay, we start with z minus 1 over z power of 4. Okay, why do we start with this? Why do we start with this? From complex algebra, you already learned that z minus 1 over z equals to 2I sine theta. Okay, you learned about this previously from when you deal with P3 complex algebra. So we start with this. Then I do binomial expansion again. So z power 4 plus 4z power 3 negative 1 over z plus 6z squared negative 1 over z squared plus 4z negative 1 over z cubed plus negative 1 over z power 4. Are you okay with the binomial expansion?
Yes.
Okay. Now I replace from complex algebra that we have learned. So I replace things inside. 2I sine theta power 4. On my right side, I'm going to simplify. Sec 4 minus 4 4z square plus 6 minus 4 over z square. This one is plus 1 over z4. Okay. And after I simplify it, I combine the similar power. I combine them together. I write like this. Okay. So now we start to continue with the complex algebra. So I times I times I times I is a positive 1. 2 power of 4 is 16. So 16 sine 4 theta. Okay, from complex algebra, z power 4 plus 1 over z power 4 is 2 I, 2I, they're missing the I here. 2I sine, sorry, this is not 2I, sorry. This one I memorized only. So z power 4 plus 1 over z power 4 is 2 cos 4 theta from complex algebra minus 4 z squared plus 1 over z squared is 2 cos 2 theta plus 6. Okay, and over here, I simplify everything by writing sine of 4 theta as my subject. So I have a 1 over 8 of cos 4 theta minus 4 of cos 2 theta plus 3 as my answer. 1 over 8, 2. So, okay, done. So as you can see, we managed to change power 4 into power 1. Try to digest. Okay, so from here, you can practice with the first part of the textbook questions. Okay, all of you already have the textbook. So what you need to do is just do the exercises that will be fall under exercise of 23A and 23B. Okay, 23A and 23B.